from Iowa. It's the desk of Lady Ada.
When I'm elected president, #1. No, welcome to another desk of Lady Ada. It's me, Lady Ada. Just took a break from looking at some debates to do some maybe some power monitoring and calculations. Thought that'd be a good way to take a break from political chat. With me is Mr. Lady Ada on camera control, and we'll be reading out questions. If you guys type questions into the many chats that we're on Meerkat, Periscope, Twitch, YouTube Live. Are we also on Ustream or no?
Ustream, no.
Ustream. Okay, so four different broadcast networks. It's still pretty good. And tonight I'm going to do something to kind of review what I worked on a little bit today. I'm about to come out with this new device, the Feather FONA, which is another one in the line of my Feather boards. This one has an Atmega 32U4 processor on it, so the kind of Arduino Micro, Arduino Leonardo compatible. It has that USB debugging and programming, battery charging built in, and then it has a cell module, a little 2G cell module. I'll make one that's 3G later, maybe. I have to find a good 3G module that will fit. It has a SIM card holder on the back. And I actually, because I recently got this like super awesome power monitor. This is the Monsoon power monitor. And it's just been like the most fun. I've actually been able to go through and do real power calculations of devices. Maybe if I have time, I'll do some more power calculations of other items later. And the way I used to do it with either an inline resistor and a oscilloscope or using a multimeter, it's it's not nearly as good as this. It's a little bit put it in your budget type item, but I use it every single week now to verify how much power I'm drawing from a circuit, and not just the average, but any spikes or movements in the current and current draw and overall power draw. And it can also do stuff like calculate how long it would last on a battery if it was using the same amount of instantaneous current it is now, which is kind of nice, especially when it's a more complicated waveform, as we'll see. So yeah, basically I thought I'd show how I'm going to measure the power draw of this. It's not super trivial to do. I'll show you some things to watch for, especially when you have a slightly more complicated power circuit. But let's go to, I guess, the computer, and I'll look at the schematic real fast. So this is the board. Here's that microcontroller. This is the JST connector, and this is the power selection circuit. Here, let me turn on TDocu so you can see a little bit more. This is the battery charger, the voltage regulator, and the SIM 800, the cellular module, and this is all the cellular module stuff here. It's actually not that much stuff. It's extremely integrated, which is really cool. And I've got the antenna out here, and there's a little Bluetooth antenna as well. I have Bluetooth to this device. And what's interesting about how this works, this particular cell phone module, is you actually don't power it from 3.3 volts. The core logic is 2.8, which you can see here, that you can probe this if you'd like, but the core voltage is 2.8 volts, and that's also the logic voltage. All the logic is 2.8 volts, which is why I have these diodes as like kind of mini level shifters. There's a pull up on these, so they act as pull low level shifters. And so you power the module off of VBAT, and VBAT is the direct to the lithium polymer battery, and it doesn't get powered off of 3.3 volts. Actually, I don't even believe I think you actually need to give it at least 3.5 volts for it to be happy. And moreover, it has very high current spikes, because the cellular module, when it's transmitting data or receiving data or connecting to the network, you'll see these big spikes, and the data sheet says up to 2 amps. I didn't quite see 2 amps, but it does depend on how far away you are from a cell tower, of course, because you'd have to have higher gain to reach that tower, and we have a lot of towers here in Manhattan. So given that you have to measure you want to measure the voltage not through the USB port, but through the battery port, right? Because if you measure the voltage going into the USB port, you actually won't be able to get just the power that's going to power the system, because what would happen is there's a hold on, let me move this over so it's a little clearer because it's in the way. It turns out, because the cellular module can draw up to 2 amps, you want to make sure that you have the battery, which has very, very low ESR. Basically, it acts like a the LiPoly batteries are really nice batteries. Like when you want to draw spikes of current from them, the voltage doesn't dip very much. They're very good at providing spikes of current. And so what happens is that this is the USB voltage over here. Actually, it's not enough to power VBAT. There's a Schottky diode, so VBus goes into the voltage regulator, and VBAT also goes into the voltage regulator, and each one of them can be used to power the microcontroller at 3.3 volts. But you can't use USB to just power the cellular part, if that makes sense. Like there's the microcontroller part and the cellular part. The microcontroller part can be powered from battery or USB, but the cellular part has to be powered from battery. A USB connection actually is not good enough to power it because of the high current spikes. Also, this regulator wouldn't be able to supply the 2 amp current spikes either. So what we're going to do is, well, first off, let's just make sure this all works. So I've got this module. I'm going to, can we go to the hover cam?
Sure. Here's a question
Yeah.
before we go. Is do you have an idea of what you think the draw will be when you're designing the product?
Well, I'm cheating a little bit because I actually kind of know what the current draw of the cellular module is, because for a long time ago I did a couple tests. But check the data sheets, because I know that the microcontrollers, the 32U4, the AVR 8-bit micros, they draw about 10 milliamps. And then cellular modules, as you'll see shortly, they're very spiky. Like they do have like a 20 to 30 milliamp current draw. If you measure it with a multimeter, you'd see that kind of consistent current draw. But then whenever it's contacting the tower or sending data or receiving data, or sending voice or receiving voice, you're going to see these big, big spikes. And sometimes multimeters don't catch those spikes. And so that's why it's important to use, especially when you're getting into wireless, it's really good to have a power meter. K-Town suggested this one. So on average, it's about 100 milliamps in use, but there's spikes that can go up to 800 or more milliamps. So again, very spiky.
Okay. I have a feeling that my thoughts about when you come up with things for engineering is the same as when I think about physicists discovering things. I don't think there's any cheating. You're just uncovering knowledge. It doesn't matter how you get to it. And if you thought about this before and you already knew it, it's all fair game.
Yeah, I mean, like I played, when I designed the FONA, because
there's like no cheating if you discover a star. Like, oh, I kind of knew it. Yeah.
Well, you also look at what other physicists are doing. So, like when I designed the FONA, I looked at the eval board for this cellular module, and they actually, they provided it with a 5-volt 2-amp power supply, and they had this really big regulator on board. And I realized, like, wow, you really do need to have like this high current capability. And I was, basically, when I designed the FONA, I was like, well, you know what, like, if you're doing cellular, you're going to want it to be portable, or at least have battery backup. Like that's the whole point. Otherwise, you'd use Wi-Fi. Like the whole point is that you're either mobile, or you want to run even when power is out, or you want having a battery backup is not like a sin or a crime in the design. Like I think if you had, like obviously if you have an Ethernet device, it doesn't make sense to make an Ethernet device battery powered. Like that doesn't make sense. If it's Ethernet, there's a cable involved. You have to plug it into the wall anyways. So having that battery powered is not so important. But given that it's cellular, I'm like, well, you know what? If I force everybody to have a battery, and LiPoly batteries are not that expensive, I think it's an okay design trade-off, because otherwise I would have had to put a gigantic regulator on there to be able to supply 2 amps. And instead what I do is I'm basically like, well, the cellular modules can run directly from a battery. In fact, some of them have built-in battery charging as well, so you can have it charge the battery that's connected to. But the data sheet is very clear. It's like V-in, 3.4 volts to 4.2 volts, and a little bit more on the edges. It's like obviously this was, anything that has a range like that, 3.4 to 4.2, that's exactly the voltage use range of a LiPoly. So I do require a LiPoly for the FONA, but I think it's a good trade to keep it half the size. Anyways, I think you want a battery on it.
Yeah. Okay, so I'm going to go to
go to
the
the
HyperCam
HyperCam.
now.
Here we are. So this is the, let me see. Oh my God, a little darker. So this is the FONA Feather, and this is that cellular module. So I'm going to start by putting in SIM card. SIM card goes on the bottom. Remember, always put the SIM card in when it's not powered on. Found that it sometimes things don't like it when you don't do that. And let's just like
SIM card services provided by Ting.
it
That's
is
right,
a Ting
Ting.
SIM card. It is a Ting.
One day,
what?
one day maybe we could get sponsors and we'll be able to do
Well,
stuff
they're
like that.
I mean, they're
We
friends
actually
of
sell
ours.
the Ting cards in our store.
They're quite nice.
Yeah, they're
And I'll tell you a thing actually that's funny. When
A thing about Ting?
a thing about Ting. The person who founded Ting did 2 cows, and then he decided he wanted to create a cell phone service, and we contacted him because we were having difficulty getting a SIM card provider to provide us SIM cards.
We had a hard time finding a carrier that didn't suck.
They all kind of sucked.
Yeah.
And so when we talked to Ting and we said, well, this is what we're using it for, they're like, oh, well, our billing plan is perfect because you don't get you don't have to get voice and cell and SMS. You use whatever if you just want to use data, and it's only like per chunk of megabyte, and it's like pretty inexpensive. So you only pay like $6 and then maybe $1 or $2 more on top. And I was like, yeah, this actually makes sense. You can cancel any time. You're not locked in. Anyways, they're not paying me to say this. We really, really like them. And we were like, this is a good provider for 2G services. And they use T-Mobile as a network. Anyway, so SIM goes on the bottom. Attach your antenna. I got one of these long antenna samples. You put your battery in. And then I have this little Feather breakout that I'm testing. It's a terminal breakout. So you have a little bit of prototyping area. But basically, it breaks out all the connections to wires for easy testing and prototyping so you can grab onto stuff easily. So this is a 2-for tester. I'm testing both items at the same time. And then I'm going to plug in this. And I'm just going to just make sure that it all works before I do some funky power measurements. So actually, I wonder I could just, well, I'll see, maybe I'll try powering it through this and see if I can get just the cell phone module power. Okay, what was I doing? So let's go to the computer. And this is the FONA test program. This is the program that comes with the FONA library that we wrote. And it basically allows you to, using a terminal, control the cellular module from like a command line. So I go my Feather and my board. So let me upload. It'll take a couple moments to upload.
Does the Ting work internationally?
It does not. It's US only.
Okay.
Yeah, it's not. We might find another provider, but the thing is actually, if you're in another country, it's really easy to get a SIM card. It's only America that's kind of
Yeah, we're
pain in the butt.
one of the reasons we sell SIM cards in our Adafruit store, and we wanted Ting because they had excellent billing and they cared about customers, is the rest of the world has easier access to SIM cards. It's been part of the GSM world from the start. And you can kind of go anywhere. When you travel to another country, just pick up a SIM card. It's pretty much that easy. But in US, it's not so easy. There's carrier lock-in, and it's been difficult.
Yeah, annoying. Okay, so yeah, here I've got
It's
my.
getting better, but
Yeah.
it's been slow.
So here's my module, and here's the list of the commands that I can use. So for example, if I type in B, it'll read the battery voltage, which is 4,207 millivolts, so 4.2 volts, which is a nice battery. I can get the RSSI, which is like how well it's able to listen to the nearest cell phone tower. I can also get the network status, and then I can do stuff like one thing I like to I can see if there's any SMSs, and I'll delete this SMS. What I do to check cell phone connectivity is I send an SMS. So I actually send an SMS Twitter. Oh, I forgot. I have to do carriage return in 1 second. And I send the words help. And this basically sends an SMS to the short code, or whatever it is, the 5-digit SMS code. And then I get a return that tells me this is an asynchronous return that says, hey, you have one SIM message. And then I can read that message. And it says, hi, this is Twitter, you get tweets, and you can use Twitter on your phone. So that's a good way to check connectivity. It's really fast and easy. Just send an SMS, and you'll get a bounce back from Twitter. And it's easy to remember, it's 4044. Okay, so now that that's done, what we want to do is actually run this with the power monitor. And, actually, I think maybe I was going to just power the whole thing, but, I want to see the USB data. So what maybe I'll do is I will open up the power tool. Hold on. Come on, power tool. There you go. Oh, I love this thing. It's totally got this like 1990s interface, but it's awesome. Okay. Okay, so this is power tool. So what this can do is it provides power, and it will graph for you the current and voltage measurement out. So what I'm going to do is I'll set the V out. I'll set to 4.2 volts, which is it's basically designed for. Also, it's funny. It's like you see the same voltages over and over again. So this is also designed for testing battery-powered items. You can tell because it says like, okay, low is 3.3 and high is 4.2 and typical is 3.7. That's exactly your LiPoly voltages. So yeah, it can do 5 volts as well, but through USB. But I want to measure the battery because that's what's going to the cellular module. So I'll try that. I don't know if it's going to work, but we'll find out. So I'm going to unplug this battery. So battery gone. And I will enable V out. And then let me see if it's still. See, I don't know if it's. I'm going to find out. And then I'm going to run. Oh, no, it's actually, okay, so it's not 0, so I'm getting something. So what you're seeing here is this purple line is the voltage, which is 4.2 volts. And then the orange line is the amount of current that is being drawn. And I can do 100 milliseconds. So you can really see the data as it's coming through here. And then it looks like on average, interface. On average, we're looking about 30 milliamps on average. Okay, I don't know how I get it to run again. Okay, that's fine. I don't want 1 millisecond. Yeah, 100 milliseconds per tick. So what you're seeing here is these little blips. Again, the firmware for this module is the firmware for the chip, the MediaTek chip inside the cellular module is not public. Like, I don't write that code, I don't run that code, you can't debug it, there's no information, so we kind of have to guess about what it's doing. But it looks like it's pinging the cell phone network, the tower, and just saying, hey, I'm still here, is there anything for me, or checking in. So let's send another SMS. We'll see if this works. If not, I have another way of doing it. So check the network status. Okay, we're still connected. And then let's send an SMS. Again, we'll send one to Twitter. And then, yeah, wow, that's a party. Look at that. So you can see, okay, so let's back that up. And then let's go to 1 second per tick. Okay, so here is where you can see, So here you can see what it's like to send an SMS from the module. Like until, before here, you're cruising at around like 25, 30 milliamps with those spikes. Everything's cool. This is when I'm actually sending the command, I think, and it has to do a little bit of processing just to deal with my commands. Or no, sorry, this is when it's still talking to the tower. And I think when I actually start sending commands, there's a little bit of a blip because it has to, process those commands. But when I actually send the SMS, you see this huge burst of data. And it's interesting because you actually are getting two bursts here. One is the sending, which is this section over here, and one is the receiving. So interesting is when you receive data, it actually takes a lot more current which is not uncommon. It often takes a lot more current to receive data because you have to process it and filter it than sending data where you just burst it out. And so you can see how trying to measure the average current is with a multimeter is really, really hard because these are extremely sharp little peaks. Like deet, 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 very, very short peaks and these are 20 milliseconds between, so this is 20, 40, about 60 milliseconds between each little spike, and each spike goes up to 130 milliamps. So yeah, how do I zoom out? Oh, no, that's not zoom out. I guess I have to do, this interface is kind of fun. Okay, so we're back here. So what I can do now is, why did my graph disappear? Whoa, interface party. I'll try running it again. Send another SMS. This time I'm going to send it one to 44.5, which I found out by accident does respond, but not as fast. Okay, so we still have that big spike. And what's interesting is even after it says it sent it, it still has some data transmission, and then you can see the data reception before the message came in. So for like the message didn't actually come in till about this point. So at this point, I guess it's negotiating like, oh, hey, like there's something waiting for me at the tower, and like I'm getting ready to receive it. And then this is actually when the SMS was received. So we can select this. And then over here, it's kind of nice. It's a little small, but it will tell you time and then consumed energy and average power. So this is about 5.5 seconds. It took 27,000 samples. It consumed 370 microamp hours. So if you have a battery, and let's just say we have 1,000 milliamp hour batteries, that's 1 million microamp hour, and then divided by 370. So you can basically you can receive about 2,700 of these SMSs. Is that the right number? Yeah, because it consumed energy. And then the average power, the average current. So it's 45 milliamps on average, but you can see here the spikes go up even higher than 200 milliamps, so probably about 300 milliamps, maybe up to. So very tall spikes, but very, very skinny. So the average current is small, but you need to have something that can source this much current. That's why a battery is really handy. Having even a linear regulator, you need to really overspec it, because if you have a good one and you have a low ESR power source, or you have enough headroom, it's okay. But these fine spikes are annoying to manage. And then it'll kind of tell you, your expected battery life if you have a battery. It'll kind of estimate it. So that's receiving an SMS. And then if we back up over here, this is when we sent that SMS. And then if I select this, it is a higher average current, 60 milliamps, but the overall consumed energy is only 110 microamp hours, not 370. So yes, sending an SMS takes less power than receiving one, at least in this location. So that's kind of neat. And then, so let's run again. So yeah, so now we're back to normal, and it's doing these little spikes. So I thought the next test we could do is, what is it? What does it take when you enable GPRS? We did an SMS message, so let's try enabling data.
What's the name of this power tool that you're using, this software?
This, I know, isn't it? Like, the naming is awesome. It's called Power Tool.
Yeah.
And you know what the power monitor is called?
I guess power monitor.
Well, why don't you go to the video, the webcam, and I'll show the brand name. Power Monitor.
This show brought to you by Power Monitor. Power brand monitor, Power Monitor.
Power Monitor.
For all your power monitoring.
It is a power monitor.
That's right. Just go to Google and search for Power Monitor.
I'm being a little mean, but actually, it's really awesome. That's why I'm being a little snarky. It's from Monsoon Solutions, and msoon.com, and they're in Bellevue, and you can kind of tell these are like individually made. I don't think they sell a ton of them, and this was recommended to me by K-Town. I don't know how he found out about it, but he's like, maybe he used it for a previous product or project, but I think it's so much fun. Maybe I'll put some other stuff on here and try it out. Okay, wow, it's going a little crazy. Okay, so let's go to the computer. Why is it doing so much connectivity? I don't know, I was messing with it. Okay, so back to measuring some power. So let's turn on GPRS. So this will enable us to get onto the data network. So, in fact, the power spikes are so high, I gotta lower the current limit over here. So that was kind of massive. So let's go and check out.
You should pick up the new power monitor accessory, Settle Down. Just plug in the Settle Down module, and it'll settle down.
Okay. So this is what it looks like when it enables GPRS. I think this is it's kind of starting. I do a couple commands. First off, I turn off a bunch of stuff and I kind of get it ready, and I set the bearer certificate. Actually, GPRS is you can kind of tell this is like really kind of ancient. There's like all this weird arcane terminology that I've like never heard before, like bearer certificates. Part of the it's like not just like user password. It's a little more complicated. But this is the enabling of GPRS. So this takes about 4.5 seconds. It draws 150 It consumes 150 microamp hours. Average current of 120 milliamps. So it does take quite a lot of current to get going. Once it's going, it doesn't use too much current. Although it seems to be there's more spikes. I don't know, maybe it's my imagination. It looks like it's doing a little more spiking because it has to maintain maybe the data connection, and it has to have higher, faster responses. Because SMSs and voice, you make a call and it sometimes takes a few seconds for the call to go through or the SMS to go through. But I think with data, it has to maintain its connection and check for data much more often. Now that we have that enabled, let's do like a basic data query. So a really easy one to do is GSM location. So this uses cell tower. I think it uses triangulation. I think, or maybe it does. I think it actually just checks what's the location of the nearest tower. See, and then it does this. But like, what's it doing? It's like clearly doing some serious data transfer. But and then it stops. What is going on? I have no idea. Someone who knows like cellular module internals, I would like love to hear about like why is it suddenly using a huge amount of current and then it like kind of stops. I don't know. Anyways, we'll do a GPRS location. So this is it connecting to a server, telling it the identifying number of the closest cell tower, and it failed. And then it tells you the GPS location of that cell tower. Maybe it just did not connect. Looks like fail code. I will actually. The only thing I'm a little concerned about is I don't know if this, if it likes being powered off of this power monitor. See, it didn't give me a bad code. Let me turn off GPRS. This is turning off, which also draws some current. What's that party? Okay. Damn, it failed to turn off. Let's try again. I mean, I can tell the GPRS is off because the current level dropped a little bit. I actually don't think it likes being, it does not like being powered off of this. Maybe I'll give it, yeah, wow, something's freaking out. Hold on. I might need to add some more capacitance, although I don't know if that's going to really help. Hold on. Let me add this. Yeah. Hold on, I'm going to add a big capacitor on the 3.3 volt line because I think it.
My theory of adding a capacitor anytime you run into something still holds true.
Yeah, well, you know, who knows? I mean, it doesn't act this flaky on a battery, but like, I don't know if it dislikes. Yeah, I don't know how good of a battery replacement this device is. Could be
well, let's just add a cap to smooth that out.
Yeah, okay. Okay, so you can actually see this is the cell module turning on. That's what it looks like when it first gets power and it like connects to the cellular network. Okay, so it's now connected. Nope, still searching. Ooh, it's not able to get on the cell network. I found that when this happens, especially if you have some really weird power stuff, sometimes you have to actually like turn it off and back on. Yeah, it's like not, it's got signal, but it's not able to get to, oh. Let me stop. Turn this off. Turn this off. I'm going to do a little bit of a hard reset. Live demo. Sometimes it doesn't work out. I'll start over. Okay. So turn this on. It's going to say there is. Yeah, it's not supposed to. Oh, you know what? It was actually trying to power the cell phone module through the battery charger. That's gross. Hold on. That's why you have to be careful when you power stuff. I gotta restart. Yeah, I think I might have jostled the cable, and then it tried to power the cell phone module through the voltage, the battery charging chip. So let me start fresh.
No capacitors would help.
No. Oh man. Why is it? This is being super flaky now. do another hard reset. Actually, what I will try, let's see what I can try next. I can try, let me go without having that power monitor involved. I also think, like, it sounds really odd, but like I think if you do really weird stuff with your cell phone module, I think sometimes the tower like kicks you off for a little bit.
What are you doing?
It's like, what are you doing? And I think it kind of tells you like go away for a little bit. Okay, see now I'm back on the network.
Don't make a phone call. Don't do something weird.
Don't do what you're doing. Okay, so let me, now that I got it back into a spot that doesn't suck, let me do a cleaner power down. And then I'm going to power it through the power monitor first. And then USB. Okay. And then see if I get this to come back up.
All right. SMS, right?
Yeah, okay, yeah, I think it. Oh, you know what? It's resetting. Oh wait, did I forgot to, I forgot to enable this. And no, it doesn't like it. Hold on. This is the fun thing about the power monitor. You have to do things in the exact right order, or it gets very upset. Unpower, disable. Turns back on. Reconnect. Vout is enabled. Oh. Excessive current. Okay, what am I going to do? I will power cycle. Plug this in. Okay, now it seems to be okay. Yeah, I forgot that I had disabled the voltage output. So it was like, hey, I'm trying to draw 200 milliamps, and I can't do that. So let's see if it can get on the network now. Okay, back on the network.
Got to be in the right order.
You have to do it in the right order. Trust me, I have gone through this game of cables.
You can't annoy the tower.
You can't annoy the tower, and you can't annoy the power meter. You can't connect a cell phone. I've determined that you cannot connect. You cannot straight connect a FONA or cell phone module to, or an ESP8266 to the power monitor, because that initial spike freaks it out. And like I think there's a setting in the parameters, yeah, where you tell the power current limit, but I keep forgetting to set this. And you have to, I guess you need to have it be more than.
Oh wow! So when you power up the power monitor, it spikes. So but you can control limiting.
You can control limiting, but I always forget. But it resets it every time, and I keep forgetting to go back and.
It's so weird. Why would it have any setting for spiking on power up? Why wouldn't it just be off and then you decide?
That's an excellent question. It's because USB limits are supposed to be 500 milliamps, and I think it's trying to like emulate.
Oh, it's like you plug it into a computer?
It's kind of like, oh, well, yeah, but it's supposed to emulate a li-poly battery, so I don't completely understand. But anyways, there's a half an amp current up limit, and I've noticed that some devices, not everything like an Arduino won't, but like cellular or Wi-Fi can, especially ESP8266, because I was measuring that earlier in the week. Okay, so run. Okay, we got our data. So now let me try doing GPRS again, although. See. Okay, connect to GPRS. Okay, this is our GPRS connection. Okay, we're in GPRS. And then let me do GSM location. Okay, so this is trying to go to the network, get data, and then it got it. So this is my CAP GSM locations. This is not this is not our exact location. It's the location of the nearest tower, but it's within a couple meters. So it's not too bad. I mean, in New York, sometimes it gets New Jersey towers, so you just gotta watch out for that. But if you keep, it basically it's a way of doing location without having to do GPS. So then let's go to, let's see. Yeah, like why is part of this graph disappearing? Okay, and it appears again. Okay, so this is the entirety of the command to open up the GPRS connection, connect to the server, tell it the cell tower information. I think it does an actual HTTP request. It's in the firmware. We don't have access to it. I don't know exactly, but there are servers that do that where you tell it the ID number of the cell tower and it'll give you the location. And then it comes back and it gives you the data. So that takes about 7.5 seconds total. Average current is 150 milliamps. Consumed energy is 306 microamp hours. So on a 1,000 milliamp hour battery, you could use this continuously for 6.6 hours. Or a 1,000 milliamp hour battery, 1 million microamps divided by 310. So it says you can do it 3,000 times. I think I'm doing my math right, but I don't know. I'm sure as soon as the video's over, I'll be like, hey, I did my math wrong. But you can do it. You can do it quite a few times. And this is not including the microcontroller, which also draws some current. And then you would want to put it into a super low power mode in between requests. So that's that. And you can also we can also get a web page. So let's get an Adafruit URL, and I have this test URL that I've had for like 4 years. So this will do a full HTTP request and read data. So this is, you can see this is the HTTP init, and then, I don't know, maybe this is the connection time, and then it's transferring data. So this is 4.7 seconds, 180 microamp hours, 140 milliamp average. So basically, I just want to show like some examples of like what the power usage is from a cell phone module, because in this case, I'm not spiking over, I am spiking to 400 milliamps. I'm not spiking to 2 amps, but it theoretically could happen. But it's important to see why it's very hard to measure this stuff with the multimeter. And a lot of people are like, well, how long will my project last on a battery? And it's like, well, it really, 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 really depends. It depends a lot. Whether you're sending an SMS, getting data, Gprs location, each one of those has its own amount of current that it draws. And how often you do it, and what your sleep mode in between, and are you bringing up and pulling down the entire GPRS connection, or do you keep the GPRS connection open? Because it's like there's so much power in setting up and tearing down the connection. Maybe it's worth it to keep it open all the time, and then just put the module in sleep mode. So a couple options to consider, and then how much time are we in?
We're at 45.
Okay, should I do a bonus or for another time?
No, let's save it for tomorrow.
Okay, so all right, you got to see the magic cable plugging in orderness required of the power monitor, but it's kind of useful. And I have some screenshots that I've taken that I'll post up, so that you don't. I have a full data capture as well. You can save the data from the power meter to, I guess, some sort of CSV type file. I think it tells you all the data points. But hopefully that was useful. So yeah, if you're doing wireless power monitoring, or you're trying to figure out what your battery life is, building something like this or using something like this is super handy. So thanks for watching. Maybe we'll show a cat. This cat threw up on the bed earlier, so I'm a little annoyed at the cat. He just pretends like he didn't do it, but it happened. Yorker. Okay, all is forgiven. If you're cute. You have to be very cute. Mm-hmm.